Hey Jason, I want to start off by saying thanks for a great semester. I had very different ideas of what this class could have been like, and you made it pleasant, and you were friendly and interesting, so thank you for that. Um, but let's also get started. This is my application. It's Conway's Game of Life. You can find an explanation on Wikipedia, and inside of the application we'll also see a link to my model for this. This is the starting pane. You have essentially a bunch of bacterial colonies arranged on a grid, and they start off with fixed ages. They're all either dead or just born. And as you click, they fade as they age, or they die off, or new ones are born, depending on the number of neighbors that you have. And those rules are written into the code, but also explained on the link that I'll show you in a little bit. You can also reset to a completely new random arrangement and go from there. Or you can start a simulation, and it makes all kinds of pretty patterns. You can adjust the speed, you can go slower, you can go back to just being paused. One of the things that I thought about for this was a handler for when the game is over. It's a zero-player game, so it's not really user interaction intensive, but at the end, you'll either clear the entire screen whenever it's of essentially infinite vacillation, or you could have something. There's a big study into this. There are things like glider guns, is the term for it, where something is continuously shooting off new particles. But this is an example of one of the ending states that's not a completely cleared board. You have this colony, this colony, this colony, and this one, which will never die. So just something to think about. It's really hard to model what the end scenario for this game looks like, especially because it could be infinite. So to check all of those possibilities would be beyond reasonable computation. But let's reset. Let's actually slow down a bit. And let's take a time to look at this. This is the About page. Just a brief description of what the game is, where I got the idea. I did the model for this in C++ once upon a time for an independent project, and now I've decided to port it to iOS and make it look pretty. So here's the link to that. This link does work if you're curious. Those are really the features. More of the interesting stuff is in the code itself, where I've done my best to be as agnostic as possible regarding what actually goes into things. It's very, very, very decoupled. So if you want to take a look at that, feel free. That project's going to get uploaded too. But this is my funsies for now. Thanks so much, Jason, and thanks for your time.